Hello, my name is Zoran Pučko. I am a PhD candidate and I would like you to present our research, automated construction progress monitoring using continuous multi-point indoor and outdoor 3D scanning. True information at the right time delivered to the correct place, which I mean users, are most important for decision making and effective construction project management. Traditionally, this activity is done manually, which is cost and time consuming and error prone. It is therefore no surprise that most researchers test effort his research into the automatic construction progress monitoring. This new method that we will present shall overcome some differences from the previous method. We actually use for our research the as designed versus as built situation, sometimes referred to scan versus BIM. We use the presence of workers who must have security helmets, which we mounted with scanners to continuously make partial point clouds from the indoor and outdoor scene. Additional information recorded like date, time, and location. After the producing of partial point clouds, they are transferred to the server, which operates software, to merge these partial point clouds into the point clouds of the whole construction building. This is the product, the 4D as-built point cloud of the whole building. In the third step, then we compare the 4D as-built point cloud with a 3D BIM model to create the 4D as BIM model. In the third step, then we compare this model to the as designed BIM model to present the difference between both models. For the method validation, I will in the following present the validation of this proposed method with a 3D range imaging, which is a part of preliminary research, which is detailed described in the paper, point cloud quality requirements for scan versus BIM based automatic construction progress monitoring. This paper is under review and not yet accepted. But for the experiment, for this research, I will present our work. First, we scan a part of a real building and simulate the work of two workers, worker A and worker B. Then, with the helmet mounted scanners, we produce the point clouds of this spot scene. Following in the second step, the partial point clouds we merged to create the 4D as-built point cloud from the whole building. The original point cloud have 8.7 million points, but the duplicate points we clean it and get the 4D as-built point cloud with 3.7 million points for future purpose. This point cloud, in the third step, we compared with the 4D as-built point cloud and to the 3D model when we use the in-house identification software to define the elements. The red elements are missing and the green are identified. So on hand this, we can create the 4D as-built BIM model. In the last step, we compare this 3D BIM model with the as design BIM model to present the differences. First, in the elements, where we can present only the elements or the elements highlighted in the whole model. And of course, differences in this model have the in the time scheduling deviation, produce a deviation in the time scheduling where we report these differences. For conclusion, the new method with 3D range imaging scanning method with multiple helmet scanners have some advantages. It can continuously acquire data from the as-built scene, indoor and outdoor. It is a low-cost equipment. Oops, excuse me. It is a low-cost equipment, but just enough for identification of elements. Of course, this research is not yet finished, so it has some open problems, which are mostly related to the merging and localization of partial point clouds. We have to finish these open problems where we have to determine the partial point cloud location and the communication with the server, which have the appropriate software for merging these partial point clouds. These problems heavy to solve. So, thank you for your attention.